Can you see now?
Yeah, looks good.
All right. So yeah, so this is problem 2 of the bronze. Farmer Gunners and cows, and each of them like to take a daily walk along the fence enclosing his pasture. So n is less than 10 to the 5. And the fence has p posts, and there are up to 2 times 10 to the 5 posts, and p is even. And the location of each post is just a different 2D point on a map of Farmer John's farm. It's basically like just like the point system, coordinate system. And the x and y position of each post is less than 1,000. So each post is connected to two adjacent posts by fences that are either vertical or sort of horizontal line segments. So the entire fence is just a polygon whose sides are parallel to the x or y axes. So the fence polygon is quote unquote well behaved in that fence segments are only potentially overlap at their endpoints, and each polygon aligns with exactly two fence segment endpoints. So every two fence segments that meet an endpoint are also perpendicular. So then each of his cows that takes the walk along the fence has a preferred starting and ending position, and each point is somewhere along the fence. It could be at posts, but it could also not be at posts. And each cow walks along the fence for her walk, starting from her starting position and ending her ending position. And obviously, like the fence is like a polygon, so there are two ways around it. And cows are lazy, so they just like to take the shorter path. And your goal is just for each cow, tell them how short the shorter path is. So the solution for this is just, well, the bounds are small, so you can just kind of maintain the position of each fence. So the input is really convenient. The fence posts are given to us in a counterclockwise order, so we know how the fence is laid out, and the x and y positions are less than 1,000. So we can just straight up have a 2D array that stores like whether or not there's a fence at a given position. And we can actually do better than that, right? We can just store like the quote unquote position of each cell on the fence. Let's just arbitrarily say that like the first fence post that they give us in the input is at position 1, and then and then the cell that's counterclockwise from that, so the one that's like 1 left or 1 down, depending on how like the next post is position 2, and so on. So and then the one after that is cell 3, and all the way until like the n minus or the nth cell is like directly to the right or above the starting cell. So yeah, we can sort of like label every single position on our 2D array as which position in the fence is in, or whether it's just not in the fence at all. And it also allows us to just find the perimeter of the fence, because like the last quote unquote position is just how long the fence is. And what we do is for each query, we just find like the difference between the quote unquote positions of the two cells they give us. And that's just the length of one of the paths around the polygon, and obviously the other path around the polygon is just perimeter minus that root. So this is a fairly straightforward problem to code. I'll just hop over to the implementation right now. So at the beginning, we just read in our input and we store them in two arrays. And then we have our 2D array that stores whether or not there's a fence there and what position the fence it's in. And of course, we have our perimeter variable. And then here we're sort of just looping through all the fences and labeling the positions of the array. So it might be like a little unorthodox implementation here, but basically dx is sort of like the difference in x position between each of the fences. So if the fence is a horizontal fence, dx is either 1 or -1. And dy is the same for vertical fences. So if it's a vertical fence, dy is either 1 or -1. And again, if it's a horizontal fence, since y doesn't change, dy is 0. And if it's a vertical fence, since x doesn't change, x is 0. So yeah, we just initialize dx and dy. And they're positive if it's going right or up, and negative if it's going left or down. Yeah. And then here we just do a while loop to just keep going until the next post. Every time, just increment the perimeter and just set the position of our current cell and change our current x and y position. Yeah, it's pretty simple. And then for each query, we just take in the cells they give us, and we take the positions of the cells. We find the difference, and that's one root. And then the other root is just the perimeter minus the first root, and we just take the minimum of the two. Does anyone have any questions? You can just drop it in the chat or unmute yourself. Or if not, I'll just end it and hit the next person, which I believe is Andrew.